Right. Now let's come back and see question numbers. Now what are over? 1 to 5 are over. Let's see question number 6 to 10. So as I've told you, question number 1 to 5 are paragraph based questions. From 6 to 10, all questions are one line answers. You need to just write in one line. After that comes your MCQ questions. After that is the assertion and reasoning type questions. So when I have to take the 6th question, let us read what it is. They said, which method is used for refining of metals? So refining of metals in the metallurgy chapter, they have picked up in the form of a question. When metal is required of very high purity. So basically when they say metal is required in very high purity, one important thing you have to remember. Let's first write what are the different refining methods which we have. What are the different refining methods? We have basically studied in grade 12th distillation process. Right, in this distillation you also have fractional distillation. Based on the difference of boiling point, we take it. After that we have a type of refining technique, that is liquation. That is one. We also have a refining technique called poling. We have one more refining technique, that is zone refining. We also do one more technique, that is nothing but electrolysis. I think I have done all, no, not thinking it, I have done all the videos of all these topics. Each one topic I have taken, I've drawn the diagrams, I have shown it in the form of a video. All the links are given in the description. Please watch that. So when you go to metallurgy chapter, all the refining techniques I have explained clearly. Right. So when I have to say, or when I have to write an answer, when you see this word metal of high purity, first thing you have to remember is nothing but zone refining. In the zone we put that metal piece, the molten metal will be moving wherever finally all the impurities will get collected to one side. Only one pure piece of the metal will be there where you will cut that. So the process where you require metal in the high purity, the answer would be, remember this keyword, nothing but zone refining. Zone refining, easy. Right, let's come back and see next question. Question number 7. Here this is an organic question. They have given the nomenclature. Compulsory one nomenclature will come. It may be from any chapter of organic and also from coordination compounds. I think recently isomerism, one complete video of isomerism is uploaded. Please watch that. It will be very useful for your questioning. Very useful for your answering for whichever question of isomerism is given. Done. Here they have asked, write IUPAC name of this particular compound. Now whenever IUPAC nomenclature is given, what should I remember? What is the order of naming the particular organic compound? So this is a series. Remember, note it in your book. What is the series? You have to always remember the order is first acid should be named, then esters, amides, aldehydes, ketones, alcohols, amines, multiple bonds, ethers and organic halides. Okay, this sequence noted. This is where you will be using it anytime. Now let me come back and apply. So here in this compound, what group is there? There is an aldehyde group. So the acid is there, not there, ruled out. Ester, not there. Amide, no aldehyde. So next in the sequence I'll be having aldehyde. So first I have to take my pen and start numbering it, put it 1. Okay, I told order of preference. Then 2, 3, 4. This is 5. So according to this, let me start. First you need to write the substituents. On the second carbon, what do you have? You have methyl. So let me write the answer as answer and 2. As soon as you write the number, you need to put in hyphen. What is this group? This is nothing but methyl. Now after that, what do we have? 1, 2, 3, 4, 5. What is the parent chain? 5 carbon chain. That is nothing but pent. Correct. So 2 methyl pent. Now where is the double bond present? It is present in the 4th carbon, isn't it? Right. So 4th carbon, did I write it correct? Yes, I have written it correct. Pent. After that, next, the 4th carbon is double bond is where? With the 4th carbon. So I am writing 4. After writing 4, I need to put dash and I have to write something here. There is, see here, after aldehyde, ketone, alcohol, amine, multiple bonds. Now this is the concept, because after aldehyde I don't have any group. I will come to the multiple bond. Multiple bond or the double bond is present at which position? 4th. So 4 I have written. Let me write 4 clearly. Ene. Alkene means ene. Now come back. What is this one? Functional group present? Al. Aldehyde, isn't it? This is Al. If it is ketone, one. Aldehyde, Al. If it is acid, oic. Correct? So this is Al. I'll be writing Al. This is the answer. So note this order. This is the name. 2 methyl pent 4 enal. right students? Yes. Now there is one more question they have asked. Name the method used for refining zirconium metal. So I'll be writing that method. So basically for refining, what is the method we have studied? We have studied different methods, but here specifically they said zirconium metal. Okay, you can note the question. Question number 8 also I'll write. Name the method for refining zirconium metal. Right. So we have zirconium metal purification, nickel purification, aluminium, everything. But there in aluminium, zinc, iron, copper, all these you have studied the extractions. But here in refining, for zirconium is one method, for one metal, and you also have one more metal, that is nickel. But here for zirconium, the metal or the method which I used is Van Erkel method. So again I'm telling you students, here because it is 1 mark question, I'm not explaining it clearly. I mean separately. Video for Van, when you type refining process for zirconium, you will get in World of Chemistry. You type it in the search in this refining method of zirconium, World of Chemistry, you will get this Van Erkel method. Or you can also type Van Erkel method, you will automatically get the video. Now let me come back and do the next question. Right, now after the 8th question, let us come back and finish off the 9th and 10th question. Let's read this. What kind of drug is phenanthrin? Okay, so in chemistry in everyday life, I think I have done one video in chemistry in everyday life where all the drugs are different classification are written in that. So when I speak about phenanthrin, first important thing, remember it is an antipyretic drug. Okay, ma'am, directly if you say how will we remember, as I'm if you think about that, I'm telling again, go back to the video, chemistry in everyday life, type it, you will get all the drugs with a mode of action also. Done. Now let us come back to this question. So what is the 10th question asking us? Which of the following complex is more stable? Right, they have given us 2 complexes here. Let's see. In the first complex, cobalt, here the metal atom is cobalt. In the second complex also the metal atom is cobalt. When I have to come back to the ligand, here ammonia is a ligand, here CO, this is capital C, this is capital O, big. This is nothing but metal carbonyl. Correct? You remember metal carbonyl, students? Yes. So when I have to see, the difference all lies in this ligand. Right. So when I have to speak about the word more stable, remember important thing, in terms of stability or the concept of stability, how well is a ligand bonded to the metal? Now this is the metal. How is it bonded? Here there are 6 ligands. If cobalt is there are 6 ligands present above, below, like this, means 1, 2, if I have to take like this, right? 6 ligands, ammonia, 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 right? But whenever I see this ammonia, whatever is there, it is a monodentate ligand, only one site of attachment. So here you write, it is a monodentate ligand, ammonia. It has only one dentate to attach to this. But when it comes to metal carbonyl, what is the speciality? First important, in metal carbonyl or CO, we see a concept called what? That is nothing but back bonding. You remember, students? So metal carbonyls have back bonding. Done. So because of this back bonding, what is back bonding? Basically there is shift of one electron, means from one atom to the pi anti-bonding, they'll shift from the carbonyl group to the metal. I did this video also for the metal carbonyl, watch it. So because of this back bonding, what will happen? Back bonding is nothing but a type of resonance only. Resonance, what is the concept of resonance? It's nothing but giving stability to the compound. Yes, students? Yes. So you can write back bonding is nothing but a type of resonance. So because of this resonance, what is the concept existing here? Highly stable. Means compared to that, this is highly stable. So what is your answer now? You have to write because of these factors, right students? Because of monodentate ligand, only one site of attachment, this is less stable. Here there is a concept of back bonding. As I told, watch the video, you'll understand the concept. You can type, you can go to your what do you say, this search engine, there you can type metal back bonding or metal carbonyls, World of Chemistry, you'll get this topic. Yes, so back bonding concept is is there. Where? Because of this resonance concept effects, because of it's more stable. So what is the answer? Which of the following is stable? This is the answer. So wherever you find metal carbonyls, you can write the answer. The particular compound is stable. Right, now let's come back and do question number 11 to 15. So question number 1 to 10 are over. In that we have seen 5 paragraph based questions. After that from 6 to 10 I did 1 mark question, 1 line answer question. Now let's see, we have come to the multiple choice questions. So careful students. So simple, very simple they are, easy, you can easily mark the answers and note the question and write the answer in the answer sheet. Most of the students, please don't tick the MCQs in the question paper. Take the question paper home and leave the answer sheet. Please don't do that. You need to write the question number as well as write the correct option in that. Now here let us read the question number 11. What do they give us? How many Faradays of electricity required for conversion of 1 mole of Al to O3 to Al? So they're asking how many mole Faradays of electricity. So basically very simple sum this is. What do they give me? They've given me Al to O3. What will happen? To convert from Al to O3 to Al, how much current is required? How many Faradays is required? Now dissociate this. How does this break up into? Exactly 2 into Al plus 3 plus 3O minus 2. Correct students? Yes. So here we very well know from conversion of Al to O3 to Al for one mole of Al means how much it requires for 1 Al plus 3, it requires 3 Faraday. Correct? For 2 Al plus 3, 3 into 2, so that is nothing but 6 Faraday. Simple. After you break, balance it. Simple of that. So multiply, the correct option is 6. Understandable, easy. Let us come back to this. What do they give us? Unit of rate constant for the reaction having rate law equation. They have given one rate law equation here. So they've given reactant A and reactant B. Right. So they've given order of the reaction on the top 3 by 4, 1 by 4. They're asking if this is the thing, if that is the rate law, what would be the unit? That means in grade 12 you have studied zero order reaction, you have studied pseudo first order reaction, you have studied first order rate law, and second order also is there. Right. So when I have to speak in that particular thing, derivation nobody will ask you anytime, but you need to know the rate constant, how many reactants it is depending, you should know half-life period, you have to know the units of that, you should know the graphical representation of first order, second order, pseudo first order and zero order. I have done all the videos of that. Go to chemical kinetics and watch it. Right. So here they've given this. So what should I do? As soon as such question is given to me, simple solving. You take this, add the orders. 3 by plus 4 plus 1 by 4 is nothing but 1. Correct? 3 plus 1, 4, 4 and 4, 1. So what is the type of reaction now? First order rate law. First order rate kinetics, they're asking rate equation. So for us to confuse, they've given us 4 options. Nothing to get confused. Always see a first unit they've given this. Second is this. Third and fourth. So for the first order rate kinetic, as we have solved the derivation also, the unit is second inverse. Remember, the first order it is second inverse. Let us take. For the second order, this is a rate law equation. Means the units for second order, unit for rate constant, molar minute inverse is second inverse. For second order, this is the unit. So remember the units and go, ready it is. Remember the graphical representation, ready it is. So in graphical representation, what will they ask you? They may ask you what is the slope of this, what is the slope of that. Suppose if this is the slope, what is the type of reaction? So you should be ready from both the sides. Yes students, done. Whenever you're studying something, try to study the complete 360 degree of that particular thing. If you study little bit and go, confusion will start. So for the first order, this is the unit. Second order, this is the unit. Third order, this is the unit, students. So easy questions. Just note the question. Question number 12 in the answer script and write option C is the correct answer. There is nothing to write the answer. There is nothing to explain in MCQs. Only the option they are going to see. So how many questions of MCQs have given? 11, 12, 13, 14, 15. So you'll just write in your paper. So question number 11, option in this case is what? Option C. Question number 12. What is the correct answer? Option C. Like that you will be writing the answer and leaving it. Right. Let us come back and do question number 13, 14 and 15. Right. So let us come back and do question number 13, 14 and 15 as I told you. So question number 13, one more MCQ question. Let's see what they have given us. They said the Vant Hoff factor of benzoic acid solution is in benzene is 0.5. So Vant Hoff factor, where do we learn? We have learned in the chapter of solutions where under colligative properties, after learning the 4 colligative properties, that is elevation in boiling point, depression freezing point, your osmotic pressure, right? And we have also studied relative lowering of vapor pressure. Sorry for that, I little disturbance, so I just turned it. Then in among all these 4 colligative properties, we have studied there's some correction factor where every time I TB into M, I TF into M, like that it will be there. So that Vant Hoff factor is what describes that. So either the compound, the molecule may dissociate or associate, right? Now they said here they've given us a clue, Vant Hoff's factor for benzoic acid in solution. Means when we dissolve benzoic acid in solution, the Vant Hoff factor have become half. Right here, what did they say? In this solution, benzoic acid dissociated, forms dimer, remains as such, forms trimer. Right, so simple. Whenever benzoic acid, what is the formula? It is nothing but C6H5, okay, COOH. Okay, I've written. Now when you dissolve it in water, immediately the benzoic acid is going to form a dimer, it's going to dissociate. So one C6H5 here, one more hydrogen bonding, as we have written one, because here oxygen is double bond, one more hydrogen bonding here. So again one more C6H5, just see here, now CO is here, again I am going to write the CO factor here with this the second one. So CO would be here, here CO would be there, and there is a hydrogen bonding, OH will be there. Let me write this completely, hydrogen, and there is a now there is a formation of hydrogen bonding at this part, and because of this formation of dimer, and the Vant Hoff factor has become 0.5, because 2 molecules separately one, they're associating like this, it becomes half, isn't it? Right, so benzoic acid, whenever it is there, it is going to dissociate in solution and forms a dimer. The correct option is dimer. So you will take your question answer paper, you write option 13, it's nothing but option B is the correct thing. So don't write B like this and leave, try to write option B. Correct. Done. Let us come back and see this. This question, again a chemical kinetics question. What do they give us? The rate law for the reaction RCl plus NaOH gives ROH plus NaCl. They have given one equation in that. They have given the rate law, or the rate, this particular thing depends on what? Rate depends on concentration of one of the reactant only, that is RCl. So when you write one of the reactant, that means what type of reaction? It is nothing but first order rate law, first order rate equation. Right. So it depends, means the rate, or the depends on rate constant into one concentration of only one reactant. Right, now what do they give? The rate of the reaction is, so when this depends, rate of the reaction becomes what they are asking. Let's read the options. Here I know one rate depends on only one concentration. Let me relate to that. Doubled by doubling the concentration of NaOH. Nowhere it is linked, isn't it? Here NaOH concept only is not there. The rate does not depend upon concentration of NaOH. Right? Done. So first is ruled out. Next option. Halved by reducing the concentration of RCl by half. Yes. Now let's see this little bit related. How? We said rate of the reaction is directly related to the rate constant into one of the concentration. Suppose if that, now I am confirmed depends on one. If the concentration of RCl is reduced by half, what will happen to the rate of the reaction? That also will become half, because both are directly related. So this becomes double, means this becomes double. If this becomes half, this also becomes half. Right, to some extent this is correct. Let me see 2 more. Increased by decrease of temperature. But whenever we see rate of a reaction, it always increases with increase in temperature here, students. So here this concept is nowhere related to this. Next, unaffected by change in concentration of any reactant. No, whenever we speak about rate of a reaction, we should have clearly one concept. Does it depend on one reactant, 2 reactant, or it does not depend on anything like pseudo first order and reaction where we take water as one of the reactant. You remember? Yes, in zero first order it does not depend only. Right. So here my concept is clear, as the rate of depends on one concentration. If the concentration of this is half, the rate also reduces half. So the correct option is B. Yes. Now the 15th question, let's see. This is again a surface chemistry question chapter. The first part of your colloids. When we start the colloids, they've given a lot of examples, isn't it? That is where this lies. Which of the following is lyophilic in nature, right? So we have two types, isn't it? One is lyophilic and one is lyophobic. So when I have to speak about lyophilic is nothing but water loving, isn't it? Philic means water loving, phobic is nothing but water hating, means it has a phobia of water, it doesn't go and attract it attached. So water hating, we said two opposite words. So they said which of the following are lyophilic, which is water loving in this. So simple, you have to remember the examples, everything directly. So what are the different types in like gum? What are the other thing? Gum is one, starch is one, gelatin is one, egg albumin is one. Again I repeat, gum, starch, gelatin, your egg albumin, all these are water loving substances. When you dissolve in water, they form bonds with that, hence they are lyophilic in nature. So the first option only is correct. Now sulfur is a macromolecule with S8, isn't it? P4, phosphorus, sulfur, S8. You have different structures also of sulfur. So sulfur is a lyophobic colloid. What it is? Water hating, lyophobic. So I'm writing here lyophobic colloid. LC means, okay, let me not confuse, like that, lyophobic colloid, right? So this is ruled out. Next, this is another option, arsenic and iron. So these two are what? One is a positive sol, this is a positive sol, or positive colloid, positive sol. What is sol? Solid in liquid. Arsenic, this is a negative sol. So metal hydroxides are positive sols and sulfides are negative sols. So for us the correct option is gum. What are the other examples you should remember? Starch, egg albumin, gelatin. Remember those, students. Yes. So let me come back now. Start off the assertion and reasoning type questions. With that, section A will be complete. Then I'll go to section B.